Okay, good morning. Welcome to
SuperMath number 18.
SuperMath18. Sorry, I didn't set up properly here this morning. We are in a new section in your geometry book, but unfortunately you have a trip today, so I'm just only going to introduce it here. Do you have the protractor?
Yep.
Okay, awesome. So we have learned so far that we can tell two triangles are congruent if they have the same sides. I'll call that x, y, z. And what was this congruence called?
It's side, side, side.
Side, side, side. And we also learned we can tell two triangles are congruent if a side, an angle, and a side are the same. Side and angle and a side. And that was called?
Angle, it was side, angle, side.
That was called side, angle, side. And today we're going to talk about angle, side, angle. Okay? And we're going to do it just with one example. We're going to make a line here. And I'll make it, I don't know, 8 inches long about. Hopefully that's big enough to show up on the camera. And I want to make a 60-degree angle going this way, so that this angle would be 60 degrees. And then I'm going to we'll make a 40-degree angle going this way. So 40 degrees going that way, and 60 degrees going that way. Okay?
Yep.
And we're going to see that there aren't very many possibilities for what that triangle with a 40-degree angle and a 60-degree angle would look like. Okay? So why don't we start with the 60-degree angle?
Let's measure it and get it right on the line.
Okay. And where's 60?
60's up here.
Okay, and luckily I can see that. Okay, so I'll put a dot right there. So if I make a 60-degree angle, it's just going to go like that. Oops. See where that cap went?
Nope.
Okay, well, we'll find it later. Okay, so there's a 60-degree angle right there. Okay, so I've got my side here that was 8, and then I got a 60-degree angle there. And now let's make a 40-degree angle there.
40 is over there.
Well, it's a 40-degree angle going this way.
Okay, so then we have our 40s here.
Okay, 40-degree angle there. Alright. And then we can draw it. This line going this way. And what do you notice here?
Well, this angle's 80.
Okay. That angle's 80, that angle's 60, this angle's 40. Alright, good. Do you notice anything else?
Well, it doesn't look like there's going to be very many of these. It looks like there's only going to be 2. This one and its flip.
Okay. Well, okay. That's a good observation. If we flip this over, we could have made a 60-degree angle.
Going that.
Going down. Let me try to make that. Maybe down like that, and then over here like that. Oh, that's close. So we could have flipped it like that. Why? What's the geometry reason here? Or not, reason from the axioms, but looking at this, why does there only one triangle up here?
Well, you can't change the position of these lines and have them be the same angles.
Okay, very good observation. And so what does that mean?
It means that you have to have the lines in this arrangement.
Okay. And what does it mean about that triangle then, if the lines are in that arrangement?
It means this is the only one.
Why?
Because you could make the lines bigger if you wanted.
What do you mean bigger?
Like if you blew this up.
Well, no, lines are infinitely thin. But I have 2 lines.
Yeah.
Okay, how many points can those lines intersect in?
Just one.
Just 1 point. Okay. And these are very specific lines. I got a line here, 40 degrees, 60 degrees. So it looks like if I know an angle, a side, and then an angle all connected to each other. So it's important to know that it's not angle, side, angle. That doesn't work. Okay? In fact, you can see why that doesn't work from the board. If I've got a side here and an angle, this angle actually could be anywhere. See how I can push that in and keep that angle the same? See that? got a bunch of different triangles. But when I've got an angle side and an angle connected, it seems to force the triangle to be only one possible size. So we'll talk more about that tomorrow. And this is called angle
Side
side
angle.
Okay. Very good. Actually, why don't you erase?